prefer this one or that one? I'll make it this one so I can see it. Is that all right with you? Yeah, there's two here. And one, 1, 2, 3, 4, 5, 6. A little much. Can everybody see there or not? Yeah? Okay. So you can see this, it's going around in a circle, right? And it's going around at 120 degrees. And I think you'll agree that it doesn't matter, it would do the same thing if it were started here, right?
Professor,
Yes.
sorry, may I also have the screen in
Oh,
here?
you wanted to? Of course, why not? Sure.
Because,
Right. How would it be if it were just this? Would that be okay?
oh, any will be fine. I just,
All right, I'll make it all of them. Why not?
yes.
Okay, so I mean, it
And-
just was very impressive to have it over there and here and here. So, but okay, sure, why not? Okay, so we're going to show 2 points of view. Okay, so on one side, you see the billiard, the way you saw it before. And on the other, you see 3 points. It looks like 2, but there's a third one that's maybe on that line there. Okay. Let me move it over, maybe we'll be able to see it better. Just a second. Here, we'll move it over. Change initial conditions. And I'm going to no, that's not what I want to do. Just a minute. Okay, my alpha I'm going to take to be 45 degrees. Start simulation. Okay. So now, I think you can see clearly 4 points. The blue points, 1, 2, 3, 4. Okay. And I think if asked to see the correspondence between this and this, I think you would agree that this must be the angle along the circle, and that's hitting at 4 points. Yes? And what could the other coordinate be? What did I change to make this into a square instead of a triangle? Well, what I changed was the angle of incidence. Right? So let me do that. Let me change the angle of incidence. But I don't want to do it with the mouse. I'm going to do it by hand. So here I have 45 degrees. Let me now do, what I really want to do is change, let me change this to, I don't know, 10 degrees. And I have another square because I didn't change that alpha. I have, there's another one here. There's 1, 2, 3, 4, 5, 6 of these. Okay. Okay. So you see, I made another square, and it's not at the same angle, and each one is separated by 360 over 4. Okay. And let me change it again. Okay. Let me change this to. 90 degrees. Okay, and I think you'll agree that those 2 points are these 2 points, right? Okay, and now let me start changing my initial conditions by hand. On the graph here, I'm going to see I get to do this. Change initial conditions. This. Okay, you see, I didn't have a nice divisor of 360, right? And I'm gonna do that again, I'm gonna move again. Again, I don't have a nice divisor of 360, right? It's not very likely if you're just moving by hand a tab like this, it's very unlikely to have a nice divisor of 360. I can try and do, so that is why it might be useful here. Just keep doing it, it's nice and colorful. Sometimes it's closer to being a divisor of 360. You see, it takes a little while before it gets all dense like that. But basically, by hand, I'm not going to succeed. I'm just going to get stripes. It's just going to fill it up. I don't have divisors of 360. But I can do it if I change by hand. Let me, what I said 90, we did 45, we did 60. Let's do 15. Does that work? Okay, let's do 15. There, so you see it, you see it being at 15 degrees, you see it going around, and where is it up there? It's up there at that top thing with all those dots. I think it's the right number of dots, 360 divided by 15, or rather, so it should be 180 divided by 15, because before when we did 90 degrees, we had 2 dots, right? So it's 180 divided by 15 is what? 10, somebody can do this, right? 180 divided by 15, get 10, you can have 50, 32. That should be 12, right? 12 dots, is that true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Yeah? Okay, so everybody understands what's going on between those two pictures, right? I'm sorry, say again?
What will become on the y-axis?
On the y-axis, it's the angle of incidence. This is 15 degrees to the tangent.
Right, so the points of 15 degrees are the 90 degrees below.
That's true. So as you say, it must be a pi minus or something like that. It must not be. I mean, I wrote 15 degrees, but it must. Why is it on top? Yeah, I guess it must be 1 minus or something. Yeah. Okay. And we can do a couple more. Let's do 75. And where are those dots? I think those dots are the green ones on top of the yellow line, I believe. Right, they weren't there before. And you can see this one is well, let's see how it's working, right? We can do some more. And that's these here, the pink ones. Right? There's one, this is a hexagon, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 points there. Okay. So I think everybody sees, I mean, it's billiards, you know, it's everybody can see what's going on there, right? You have complete understanding of this. This is a circular billiard table. Now I'm going to change that. Self-defined, okay, and you can see, right, this is not what I'm going to make. I'm going to write, this is going to be 1 plus here, 0.1 times cosine theta. Okay. You don't see the change. It still looks like a circle, but it's not. It's a little bit, how do I tell you that? I'll just tell you it's not. I think I'll say that it's flat, you see the flat place, because there's very little resolution, you know, you can see each individual pixel, it's very old software here. I think you'll see that that vertical place on the left is longer than the vertical one on the right. It's flatter on the left side than on the right, but just barely. Okay, let's let us change the initial conditions. Let's do this with the mouse. Ah! Notice this was just a random choice that I made just now. And look what it's doing. We didn't see anything like that before, and I'm telling you, there wouldn't have been anything like that before. Okay? And now we're going to move again. I mean, it changes so little that you can barely see it on the shape of it. This is still billiards. It's still just bouncing off. Completely elastic collision. It's just this change in shape that did that. Let me move. Now I have a line that goes all the way across, but you see it's wavy. Again, this one's wavy. It's going to fill up, but it is wavy. Is it going to continue to be lines like that? Let's see what happens. No. Note that over there, that was 2, if not 3, because it's periodic, so the left side and the right side are each half of 1. This one is 3. And you remember before, what the billiard was doing when we had these things that were up there, was going back and forth between 2 pieces of it, and now it's going to 3 different pieces. Right? Okay, now it's going all the way around again. This one doesn't. This one does this. It's green. This green circle goes around the white circle. And keep exploring. There's a line, curvy line. So I still mostly have lines, but I have these funny circles, these ellipses. Go back up here, do something here, say here. Let me change by hand. Let me take a value here that's 45. And let me take a value here that's, I guess maybe 1, maybe I'm not quite sure how this there. Let's see what happens. Okay, so you see that this time by choosing, just as before, when I chose a fraction pretty closely, I managed to get those dots. And now, when I can choose a fraction here, that's 1/4. right? I have 4 points there. And that, this one here, let's see if there's a laser pointer or something. Is there a pointer? Oh, there's one of these. Should I put on one of these?
Your voice is already clear. I think there's already a speaker
There's already a
on the desk.
So by aiming at fraction, before I was getting those dots, now I'm getting these circles. It's a very skinny circle, but it is a circle there. Let me see if I can aim at, let's see, change my initial conditions. I'm going to continue to move. Let's see what happens if I take something that's kind of close by. There, I have again, of course, a ring of 4. Now I'm out of the ring of 4. You see that it's going to close up. And I think you'll notice also that the area where there's a ring of, where there's 2s, this is wider. That was pretty easy. That one I just did at random. I was just moving around, and I got this thing with the 2s. The 3, I also kind of got at random, I think. I don't think I've, but the 4 is sufficiently thin that I don't think it would have been hard to get at random. I had to put it in by hand, the way I had to put in by hand those other orbits, right? And I mean, I should say, it's all very clear. This is really billiards. This is really bouncing off this. This is just slightly off of a circle. This is really what it does. And the rest of the class is dedicated to explaining, oh, what is that picture? Why do we get this picture? And you've done Hamiltonian mechanics, right? Have you done something like this? No? Do you know what would you say is the name of these things? These circles that are appearing? What would you call those things?
I think some maybe related to Poincare.
I think I've learned to call these resonances. I'm not sure. Or
Yeah.
anyway, Poincare certainly is the right name.
Under the name of Harry.
Founded. Not only did he found Hamiltonian mechanics, but basically every result that we use today is based on him.
Yeah, I know it's a famous phenomenon.
Yeah. Okay. So I think this is so nice that we can just show this with something so simple as billiard that we really understand that this is really bouncing off of this. These are elastic collisions. That's all that it is. You know, you saw before, and now they're going to make this beautiful picture. I guess the one thing we could do perhaps is we can increase the perturbation. Here, this was a circle, 1 plus 0.1 times cosine phi. Now I can perturb it more. I can change that 0.1 to 0.2. And right away, I have I see a very curvy thing. And in fact, it's curvy, but it's in fact a curve of islands, and I don't think those islands are going to close up. All right, it's a curve of islands. We're going to explain all of this, I mean, more or less, in the class. You can see why I said that you might want to come. Right, it's awfully nice, isn't it? Here, let's cruise around some more. Here we have our 3 island, and he's fatter than he was before, isn't he? The 3 island. He used to be to take up much less vertical room. Again, it looks as though these little blue things are islands themselves, doesn't it? At least for a while. They don't seem to be filling in. They seem like narrow circles themselves. Keep exploring this 3 thing. This one's a 5, and it's before there was no chance of running into the 5-1 well, it was a little bit of a chance with the finger because it was too narrow. But now, you can see it's gotten quite fat. Back up to 5. Seven. See, now it's getting very easy to run into these things. Didn't used to be. Now this one closes. And what do you think is going to happen here, given that curviness? It's the 2 island. The 2 island now is huge. And also, don't you get the feeling that there's circles around the circles? I think this is still the 2 island. And this is islands around the island, the 2 island, if you agree with that. And by now you can see it's kind of hard to avoid the islands. You get some that go through, but mostly as you're cruising around. Is this going to close up? No, I think this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 island there. I mean, it's 16 set of dots, I think. And they are surrounding this thing here, which is 1, 2. Another 5 island. This one should look like the one above. It's only, we're just sampling a different part. The one that, the 5 island above, I think this is, if we move around properly, we'll look a lot like that one. Okay, so let's stop this for the moment, as nice as it is, right? And now let's try and discuss what makes this happen. I think I do escape. No, I don't want to do that. I always advance the room. I just want to not do full screen. What is it that I do again? I do not want to escape. What is it? What is it that I do?
Just Command Tab.
Say again, command. I written it down, of course I wrote it down, it's return, no, it's no, it's return, toggles. Oh, well, I guess I'll, all right, too bad. I guess I will. Ooh, no, even now I'm not out of the first one. What do I do? I forget. Why didn't I write it down? Why didn't I write it down? It's not hidden behind this. Oh, no. This can still be the screen. Okay, so Option Enter. Option Enter. I say I should have done Option Enter. Okay, somebody remember that for me? Option Enter. Toggles full screen versus not full screen. Option Enter. Okay, somebody will remember that. That's what it says here. Okay. Anyway, at least if I manage not to do it again, we'll have seen it all. Okay, so Hamiltonian systems. What is a Hamiltonian system? Well, assume a function, h of n p's and n q's, and they evolve as q dot equals dh dpi, and p dot is minus dh dqi. We saw that, some of us did anyway, I believe it was yesterday afternoon. It was in spatial analysis and reaction diffusion. Was that yesterday afternoon, or was that yesterday morning?